Hey guys, so I'm going to go over some examples of 3.6 just to kind of show you um, how to do some of these examples. So if you're working on any examples from the homework, maybe 3, 5, or 7, this should be a video to help you. So in this example here, the polynomial given to us is 8y to the fourth minus y equal to 0. And we're being asked to first identify the number of solutions. So the number of solutions here would be 4, because the degree of the polynomial is 4. Okay, so this is the fundamental theorem of algebra, saying that if you have a polynomial of degree 4, then that polynomial will have 4 solutions. Okay, and now and then it says to find all the solutions. And so some solutions might be real, they might be irrational, they might be imaginary. So let's go ahead and find. So from this one, I can see that I can factor out a greatest common factor. So I'll take out a y, and I'll get 8y cubed minus 1 equal to 0. From here, it can still be factored. So 8y cubed minus 2y. I could write this as maybe 2y cubed minus 1 cubed. And so here I have a difference of 2 cubes. And the difference of 2 cubes is the factor pattern is a cubed minus b cubed is equal to a minus b times by a squared plus ab plus 1, or plus a, or sorry, plus b. And so in our case here, a would be equal to 2y and b would be equal to 1. So let's go ahead and apply this here. So I would say 2y cubed minus 1 cubed is equal to 2y minus 1 times by 2y squared plus 2y times by 1 plus 1 squared. Sorry, this should be b squared up there. Forgot to put that there. And then if I simplify this, I get 2y minus 1, and then this should be 4y squared plus 2y plus 1. Okay, so what we did is we took this polynomial right here, these polynomials, which are the same, and we factored it into this. So let me rewrite what my factors are. So I still have that y there. So I have y, and now I have 2y minus 1 times by 4y squared plus 2y plus 1. Now let's go ahead and see what factors we end up with. So I see that right here y would be equal to 0. Okay, and then 2y minus 1, I see that if I take 2y minus 1 and set that equal to 0, I can solve that algebraically. So when I solve that algebraically, I should get, see, I'll add the 1 to both sides. I get 2y is equal to 1, divide by 2, and I get y is equal to 1/2. So here I found 2 solutions of my 4 that I have. So now that I have those, I need to find the other 2. Now the other 2 are going to come from this polynomial, but this polynomial is not factorable, and I can tell that it's not factorable because if I do a times by c, which would be equal to 4, there aren't any factors of 4 that would add to give me 2. So if there aren't any factors of a times c that would add to be b, it's not factorable, and so in that case I'm going to use the quadratic formula. So quadratic formula where a is equal to 4, b is equal to 2, c is equal to 1. So I get x is equal to negative b plus or minus the square root of negative, or of 2 squared, minus 4 times by a times by c all over 2a. Okay, and then for me, I'm going to do some of that math there. So x is equal to negative 2 plus or minus the square root. So I'm going to start here. So 2 squared is 4, minus 4 times by 4 is 16, times by 1 is still 16. So 16 there, all over 8. Simplify more. So I get negative 2 plus or minus the square root of negative 12 divided by 8, and I get x is equal to, here I'm going to split this, so negative 2 over 8 plus or minus the square root of negative 1 times by 4 times by 3. So I'm choosing to do this because 4 is a factor of 12, and I could take the square root of it and then divide it by 8. Simplifying it more, negative 2 over 8 would be negative 1 over 4, plus or minus, and then the square root of negative 1 would be I, and the square root of 4 would be 2. So 2i, and since I can't take the square root of negative 3, I'll leave that as the square root of negative 3 divided by 8. And then I can simplify this one just a little bit more. So I have negative 1 over 4 plus or minus, this would be I over the square root of 3 over 8, or over 4 this time. So here 2 and 8 would just be 1 over 4, and so that's why I have it there. Now your book or your solutions, if you can't completely get rid of these right here, of these denominators, and if they're the same, usually we'll just write this again kind of as one thing, so over 4. So that's probably what you'd see. And here are the other two solutions. So here's two solutions here, here's one, and here's one, which gives us our total of 4 solutions. Okay, so that's an example that you should be able to model for 3, 5, and 7 in your homework. Now these ones, 3, 5, and 7, they might not always use the difference of 2 cubes. You might have to factor a different way, but you still need to factor and use some factoring patterns. Okay, so hopefully that helps you for those ones.